Okay, well today is September 19th, 2020, and Eric's been in the Spokane area for about 2 months, and for about the last 4 weeks or so, about 1 month straight, about six days a week, we've been working on the audio modulator rack. It's probably about maybe 90% done.
Yeah.
And we still got to powder coat this panel, but this is pretty much the full setup, and then there's another panel that will go on the inside horizontally, and we'll do a walkthrough of that. And what we've done so far, most of the wiring is complete. There's just a few extra little things we need to do. Do you want to maybe explain kind of the sequence of starting with audio signal, going into the control amp, and then kind of the flow chart of...
So basically this is kind of the power section down here, rectifiers and dummy loads and what have you, but the signal starts out of this HP audio oscillator, and then there'll be patching arrangement here.
So there'll be plugs
and what have you, and then this is the control amplifier, which is will be under construction. This is just kind of a blank right now, and that takes the output of the audio oscillator and steps it up about 20 decibels, and then the output amplifier, then that about another 10-20 decibels to gain depending upon how you set it. So this basically starts off at around 1 watt, and this ends up at 1,000 watts. And then of course the scope.
1,000 watt high voltage audio.
Yeah, so the transformer, output transformer determines the voltage. So when we get to the back side, I'll point that out.
And the scope is just to monitor what this is...
What the waveform looks like, make sure there's no distortion or...
At the output?
Yeah.
Right.
Well, anywhere you patch it in, but it's supposed to be on the output all the time when you're not using it for something else.
Now this control amp right here is a highly specialized one, specific for this application, but possibly we're looking at developing a commercially available audio amp based on this basic design.
Well, the output stage of the commercial audio amp is inside this. So it's a design that operates somewhere between 60 and 120 watts. In this case, it won't need to put out more than 30.
So the one that we're looking at possibly making available is for your home stereo system.
Right.
Bell Labs, Western Electric.
Style. In fact, the actual unit duplicated. I forget the model number, but there's one design in particular that's going to be duplicated. And being that it's not under such a heavy commercial restraint, there'll be, like it is being tested in here, the power supply will be much more sophisticated and rugged. The voltage will be much more stable.
So we don't have a timeline on that, but that is a product that we want to put into production and make available, is a Eric Dollard designed home stereo audio amplifier. And this is, its roots are based on what's inside here. So I'll get the camera and we can kind of go through the inside there. Going to point it out from that side, or?
Let's start from the top down.
Okay.
So we got the 2 wire ways. We got the 1 wire way for the high voltage, high frequency.
That's with all the red cables in it.
That's a special high voltage wire. And then this, of course, is the output amplifier. So this is the output of the output amplifier. And this is the direct current in, and this is the direct current to the transformer down on the bottom. So that's what connects to the tubes in the output amplifier. And then the output itself appears on these high voltage radio frequency connectors. And that'll be 2,400 volts when it's delivering 1,000 watts of power. So basically 110, 220 in, and then 2,400 volts out. Of course, this is 60 cycle sine wave, but this can be any waveform in the ultra low frequency to very low frequency band, which is 30 to 30 kilocycles.
30 to 30 kilocycles.
Right. And it doesn't have to be a sine wave, it can be any waveform whatsoever, including music.
Okay.
So, and then the inside was very specialized. So we have, in order to protect the transformer when it's not delivering power but only potential, we have 20 incandescent lamps hooked in series here as a 150 watt dummy load. And that connects across the output coil of the modulation transformer. In case any transients or overvoltages or what have you, the light bulbs will protect the transformer from arcing over inside. And then it has built-in spark gaps on the primary to help prevent that from happening. And then you get the camera on the other side, and I can show the
Okay. Oh, and,
The wiring.
and here's the low voltage
the low voltage wireway, yeah, and the grounds.
here.
So the grounding here is all EMP class grounding system. Everything's done low impedance. There's no reliance on the power cord or the rack for grounding. As you can see, bring the camera over here. So the power comes in here normally, but the ground is its own system, independent of the power wiring. And it's designed to have very low impedance, inductance, and resistance, because this thing's going to be operating around some pretty powerful Tesla equipment. So there can't be any standing waves or things building up. So every object in here has its own ground, and then it's brought back. All the grounds are brought together at one point only, and then there's the ground stud that connects it to the earth. So in this type of configuration, there's no way that any extraneous circulating currents can get in between the chassis or the ground systems or in the rack. Particularly even, if like the power line shorts to the case or whatever accidentally, none of that current will flow through any of the metal structure. It'll all be taken away by the ground system. Minimize damage to other pieces of equipment.
And do a little walkthrough back here.
Yeah, so this is where all the high voltage stuff connects together with these banana jacks. We don't have all of them yet, but it selects either balanced or unbalanced output, kind of like it was with the MWO. And then all the system grounds can be brought in here. And then we have the voltage divider networks on the bottom. They're capacitor voltage dividers.
That's these right here.
Yeah, so the oscilloscope can be hooked to the output of the output amplifier without damaging the oscilloscope, because the voltage is 1200 volts per phase, and you don't want to put that in the oscilloscope. And then, of course, the output and input connectors, and then this is terminal board for these capacitors and resistors here. Determine the ratio of the voltage divider. So right now it's set at 100 to 1. So 1200 volts on a phase will end up 12 volts to the oscilloscope, which is about a good range for it. And the difficulty is making that step down frequency independent.
I'm going to go over this panel right here.
Okay, yeah, I'll put that in. So this is the medium voltage rectifier. This runs the output tubes in the control amplifier, the audio amp output tubes.
And there'll be a big cap underneath.
Yeah, and there'll be the harmonic suppressing bypass capacitor for the output transformer, which will go underneath, sitting above the output transformer. And this closes the whole structure up into a box, so things have a hard time going in. And a tube, let me get the tube that goes in there so you can see what it looks like. Only got one.
That's when we need to order a couple more.
We should at least have two.
And then these 810 tubes here, these were shown in the other video, the first walkthrough video.
These will be used in all the audio amplifier designs. 5R4GY, so that goes there. So this is the The low voltage rectifier puts out 600 volts and the high voltage rectifier in the back puts out 2400 volts DC. So basically all of this down here is the power part of the rack. Power supplies, input, output power, and the protection and measurement arrangements for that power.
Do you want to give a walkthrough of kind of what the basic idea on the RF rack is?
Yeah, I think we already did that, but you want to do it again?
Yeah, just kind of, you know, like a flow chart of each component.
This is where the output tuning network is going to go, or the coupling network, which can be any arrangement of things depending upon what you plug in. And then in the same position as the power amp here, or output amp, there'll be one here. This will use a different set of tubes. And then the control amplifier in this case will only be the DC control, not the RF excitation, because below that will be a Collins 32V 100 watt AM ham radio transmitter that will serve as the exciter for the particular Tesla transformer arrangement that's going to go to this. And then the bottom again will be all the power transformers and that kind of stuff, which is all sitting right there in the rack. Now you want to...
Yeah.
So the other rare find was the modulation choke. This is out of a major radar unit. Appears that it's never been used. It was an absolute miracle to find it. But that serves as the modulation choke. And we have the high voltage filter capacitors. And we have the capacitor that works with the modulation choke for the network that connects the audio frequency amplifier to the radio frequency amplifier. It goes through a high pass network to keep the DC out of the modulation transformer. And then this is the filter choke that works with these capacitors. And these are some coils we got that will probably be used in some kind of tuning unit. Found these laying around. Kind of a priceless find. Particularly pairs of them so you can make stuff push-pull. I think these are going to be more down in the AM broadcast band, but I don't know until I calculate the inductance. So these are a major part of the RF section. And the tubes I think are packed up. Let's see. You can open them up. They're pretty solidly packed up. I don't think I'll take them apart. Maybe you can see them through there. It's iMac 4250 tetrode, pair of them. So these will deliver 1,000 watts in the AM mode, a little over about 1,500, and they'll deliver 4,000 watts in the pulse CW mode. So that'll be the rating of the RF section. About 1,500 watts AM and about 4,000 watts pulse CW, which should be enough to make a rather significant discharge in the Tesla transformer.
So that's it. We'll keep giving updates as we get more of this complete, but this pretty much accomplishes this round. So we have a little bit more to finish on audio rack, and then we'll get started on the RF rack. And we still have to build the Tesla coil, and we discussed that in the first video with a couple pictures. I think that was in the Marconi building.
Yeah, the RCA Marconi building in Bolinas.
So you can go watch that video and you can see what kind of Tesla coil arrangement we'll be building for this. Are there any kind of, in case anybody has access to parts, we're looking for these type of indicator?
Dialco type indicator lights.
And these are little incandescents?
Yeah, they're the little.
So if anybody has a source for these or wants to donate them to the project, let us know.
Yeah, they're hard to get.
And these meters are actually reversed, but and this particular unit has a little section in there. This is another layer, and then another layer. And this is kind of the arrangement of the pulse modulator for the multi-wave oscillator units we manufacture, which only has one divider plate with the high voltage and low voltage sections divided. But that's what the blank panel is, the back of that unit that has to be developed. Alright, well, stay tuned, and if you go to ericpdollard.com, EPD Laboratories Inc. is a 501c3 nonprofit corporation. All donations are tax deductible. And on ericpdollard.com, if you click on the donate button or you scroll down and you look in the right column, there's an address if you would like to send a check or money order to help support some of the projects, or you can donate by PayPal. This entire project is kind of a personal project I'm working on with Eric, so basically I funded this whole thing out of my pocket. So donations are not going to this project here. That's for projects going down at the shop down in Nevada. And
that's where the next step's supposed to occur after this. The one that's 5 times bigger. That's what the donations are going to be really needed for. And so sometime in the near future, Yari and I are going to take some stuff down there that's up here at the shop for Eric, and when we get down there we'll kind of highlight what that is and what that project is going to look like and what kind of funding we're going to need to bring that to completion. So although this is kind of a large scale one compared to what most people will build, this is still pretty small scale compared to what Eric is going to be putting together down there at the shop. So this is going to blow people's minds, and the other one is going to be terrifying. The outer limits. It'll be the outer limits.
And make sure to go to EnergyScienceConference.com and register for next year's conference. The 2021 conference will be at the Kootenai County Fairgrounds in Coeur d'Alene, Idaho, which is about 50-minute drive from the Spokane International Airport in Spokane, Washington. And when you register, it might say 2020, but those registrations will just be carried over to 2021. So if it does say 2020, don't worry about it. You're definitely going to be registered. And make sure to go to emediapress.com. You can find Eric's most recent presentations on Heaviside and Fortescue. And those are currently available by themselves, or you can get a big discount getting the package. We just released James DeMeo's Dr. James DeMeo's presentations on the orgon and the ether from the same conference this past July. And here in a few days we're going to be releasing Peter Lindemann's talk on John Bedini's glass case motor. And Eric is taking off here in a couple days, and so we're going to try to get the rest of the conference presentations rolled out by the end of the month.